So I'm going to read that paragraph in the beginning there, and then we're going to talk about how to set up an observation or an experiment. It says, 2 students leave campus every day for lunch, with a note, of course. Because they have such a short lunch period, they wonder if it's faster to go inside, like a fast food place, to order, or to drive through. Okay, we're not talking about mobile ordering or anything like that. This is old school. So each day they just flip a coin and decide whether they're going to go inside to order or do drive-through. And they, what they do is they record the total length of time it takes from the moment they get to the parking lot of the restaurant to the time they get their food. So that's the data that they collect. And they do this for several weeks. And then they analyze their results and determine that going inside actually takes about 2.5 minutes less than doing drive-through. So their conclusion from that, from their data collection, is that it's faster to go inside. Now we know that now mobile ordering kind of makes things even faster. But this just kind of shows you, it says right here under asking statistical questions, that the scenario above about the 2 students illustrates the 4 steps of the statistical problem-solving process. Okay, here's what you do in statistics. You ask questions, clarify the research problem, and ask 1 or more valid statistical questions. So that first blank is statistical, and we're going to talk about what makes a question statistical or not here in just a second in our first example. So that's the first thing you do, is you ask a statistical question. And then you're going to collect the data. You're just going to design and carry out an appropriate plan to collect the data. So design, darken that up a little bit. Oh, my pens are running out of ink. Alrighty, and then step 3 is analyze the data. You're going to use appropriate graphical and numerical methods to analyze the data. At the very beginning of this class, we looked at different types of graphs: dot plots, stem and leaf plots, histograms, bar graphs, pie charts. So most of the time what you're going to do is you're going to organize your data into some kind of graph. And then you're going to look at the numbers, maybe use some formulas, find z-scores, anything like that, and analyze it. And then lastly, you'll take your results and interpret them. And that first blank, write, draw conclusions. That's the interpreting results, is you're going to draw conclusions based on the data analysis. Be sure to answer the question that you asked in step 1. So it comes full circle. That last little blank right there is answer. Be sure to answer the question that you asked up there in step 1, the statistical question. So those are the 4 steps. This little sentence right here is really important. It says that the 2 students that did a little experiment at the top of the page there, they asked a valid statistical question because, and here is why it was a statistical question, is because the answer to their question, whether it's faster to do drive-through or go inside, it was based on data that varied. Okay, the data is going to vary from day to day, from restaurant to restaurant, from time to time, and that's what makes it statistical. So this very first example, and you're going to have some homework problems like this, it's just going to say determine if each of these is a valid statistical question, and kind of like why or why not. So A says, how much money does Mrs. Lewis have in her wallet right now? With that, like right now, if I got my wallet out and I told you how much money was in it, is that going to vary, or is that going to just be one answer? Just one answer. Okay, it doesn't say on average how much does she have in her wallet, and we collect data over time. So this is not a valid statistical question. Just write not valid. The reason is because the question can be answered with a single value that doesn't vary. Just write single value that doesn't vary. And you can use that same exact answer on any of your homework problems or anything like that. If you know it's not a valid statistical question, the reason can probably most likely be because it's a single value that doesn't vary. Now B says, how long can students at your school hold their breath on average? What do you think? Is that a statistical question?
Yep.
Yes, because you would have to collect data on students at your school. It says on average, so you'd probably have to pick some kind of a sample because you can't ask everybody and you can't test everybody. But the data will vary, and that's the reason. So let's put valid. And the specific reason why is data will vary. It'll vary from student to student. C, what proportion of U.S. adults exercise at least once a week? Is that going to vary from person to person? Are there going to be lots of different answers that are given to that? Okay, so that's valid. Data will vary. And lastly there, part D says, what is your favorite TikTok of all time? No, that is not going to be valid because you're just asking that is going to be a single value that doesn't vary. What is your favorite TikTok? We're not saying a group of people on average, what is the favorite? So single value that doesn't vary. So I think those homework problems will be very easy for you. You can knock those out really fast. All right, so we've covered how to ask a good statistical question because that's what your observational study or your experiment would be based on. Now we need to talk about some really important vocabulary here. On your quiz that you'll eventually have on Friday, you're going to have a little vocab matching section, okay? And I'm going to put these bold words that you see down here. We'll define them on the next page, but I'm going to put these on there in the matching section. Census, sample, and population. So let's read this. Suppose we want to find out what % of young drivers in the U.S. text while driving. To answer the question, we're going to survey 16 to 20-year-olds who live in the U.S. and drive. Ideally, we would like to ask them all. So ideally, I would like to ask every single person who is 16 to 20 years old who drives, whether they text while driving or not. That would be a census if I could ask every single one. But that's not practical. It would take a lot of time and money. Some people wouldn't be reachable, okay? So instead of asking every single person, instead of taking a census, instead I would survey a sample of 16 to 20-year-olds who drive. And they would represent the entire population. That sample would represent the population of people I was interested in knowing something about. So turn your page and we're going to formally define these so you know exactly what definitions you'll see on the quiz on Friday. Population is the entire group of individuals you want information about. Entire group. So if you're reading a word problem and you're asked what the population is, to answer that, just say, well, who is it that I'm wanting to know this information about? It's the entire group. A census is kind of a rare thing, and that's if you could ask everybody. And it's data collected from every individual in the population. And the U.S. does a census every so often. It's typically mailed to homes, and you answer questions, and that's how they gather data. It's this huge thing, and it's not done very often because it is hard to reach people. So a census is if you get to collect data from every individual. A sample is generally what we go with instead of a census, and a sample is a subset of individuals in the population from which we collect data. So sample is the few people that we use to represent the entire population. So I think these next examples will probably, if they're not very easy for you to understand in the beginning, they'll get easier as you see more and more. Okay, these are going to be some upcoming test questions, quiz questions and stuff like that. It says, identify the population and sample in each of the following settings. So you need to tell me the population and the sample. Part A says, the student government at Valley High School surveys 100 members of the student body to get their opinions about changes to the Bell schedule. So let's just organize our thoughts. Let's figure out population. Who is it that I'm wanting to know information about? And then sample, who did I end up asking that question to? What do you think the population would be if it says that we're going to survey 100 members of the student body and get their opinions about changes to the Bell schedule? Whose opinion do I really want information about? The entire student body. Yes, that would be the population. Very good. So let's write all students at Valley High. And you could write that differently. You could say the entire student body. Everybody, all the students. But I can't survey all the students at the high school because it would take too long. It's not practical. So the sample is what? That's the easy part. Yeah, it's just the 100 people that I actually get to ask. So 100 students. That's the sample. And that's it. Let's look at part B. The quality control manager at a bottling company selects 10 cans from the production line each hour to see if the volume of soda is within acceptable limits. This one's a little bit different. Let's see, population. Don't think that population is always people. In this case, what is it that the quality control manager wants to know about? What is he collecting information about? The cans, right? But specifically, is it all the cans in the factory? Is it like all the cans in the factory for that particular day? Is it even more specific? Yeah, it's that each hour that's really specific. So he's just pulling 10 cans every single hour. So he really wants to know about the cans within that 1 hour. He's checking that 1 hour's worth of cans to see if they have a good volume. So all cans filled that hour. Or all cans filled in a particular hour. Now the sample, I think, is going to be easy for you because you can always just read and see, well, you know, how many students or how many cans are pulled and so forth. So here it's just 10 cans. I'm underlining the word all, population, on both of these so you can see the consistency. Population represents all the individuals we want to know information about. I don't really think you need any more examples on that. So now we're going to move on. And I'm going to teach you about the difference between observational studies and experiments. Okay, that's a really important, it's like the cornerstone of a lot of statistics, even in that, like the AP Stats class. This is something that they struggle with, and so I want to make sure that you understand the difference between an observational study and an experiment. This stuff's interesting to me. A sample survey usually aims to gather information about a population without disturbing the population in the process. So I'm going to highlight that. A sample survey, basically it allows me to gather information like just on a survey. Hey, answer these questions. It's not going to disturb you in any way. That's one kind of observational study. Other examples might include just watching the behavior of an animal in the wild, tracking the medical history of patients to look for associations between things like diet, exercise, and heart disease. So it's just observing. It's not disturbing the thing that you're observing. You're just collecting the data, okay? Observational study. In contrast, experiments don't just observe or just ask questions. They actively impose some treatment so that they can measure a response. That's what an experiment is. You're imposing a treatment. And those are the problems that we've been looking at, like, hey, I split you up into two groups. One of you takes a placebo and one of you takes this other thing, and I'm going to analyze the results and see if this medicine actually helps or not. That's an experiment. They can answer questions like, does aspirin reduce the chance of a heart attack? Or do plants grow better when classical music is playing? So here are the formal definitions, okay? This could be in that little vocab matching section on your quiz. An observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. Observes and measures, that's it. I can ask you questions, I can just watch you and analyze things that happen, but I'm not going to influence your response in any way. Whereas experiments deliberately impose treatments on individuals to measure their responses. Okay, let's read this little paragraph down here. An observational study is a poor way to gauge the effect that changes in one variable have on another variable. To see the response to a change, researchers must impose the change. When the goal is to understand cause and effect, experiments are the only source of fully convincing data. I'm going to go ahead and highlight that. If I really want to understand cause and effect, then I need to perform an experiment. I need to know if something that happens causes a change to happen. And I can't just do that by observing. For this reason, the distinction between observational studies and experiments is one of the most important ideas in statistics. Okay, last page of the notes. All you're going to have to do, we can get through this really fast, is read the scenario and determine if this is describing an observational study or an experiment. For a lot of you, this is going to be super easy. Part A says, 90 residents of a retirement community were selected at random. Each member of the sample was asked a number of questions, including questions about blood pressure and exercise. So all I did is I picked 90 residents and I asked them questions. Residents who exercise more often were less likely to have high blood pressure was the conclusion that I drew from that. Would this be an experiment or an observational study if I asked them questions? It's just an observational study. Okay, I'm not influencing their response in any way. It's like filling out a survey. So let's just write, we can keep it pretty simple. Observational study. There are no treatments. How could let me stretch your brain just a second here. That's all you need to write. Okay, so just write that and then listen so you can answer this question for me. How could I change that into an experiment? Instead of just asking them questions, if I'm wanting to know if exercise, how often you exercise affects your blood pressure, like that cause and effect thing, and I decide I need to do an experiment, what's one way I maybe could do that? Split them up into groups and tell one group, don't exercise at all, and I'm going to measure your blood pressure over time. And this other group, or maybe, you only exercise once or twice a week, and this other group exercises 3 to 5 times a week, and we measure it there. Very good. So you'd split them up and impose some sort of treatment. Great. Part B. Students in a statistics class were divided into 2 groups at random. Students in one group were given a set of words to memorize in a room with music playing. Students in the other group were given the same list of words to memorize, but in a quiet room. Students in the quiet room were able to memorize more words on average. Is that an observational study or an experiment? Experiment. Why? Why wouldn't I just say, well, I just observed them memorizing the words? It's an observational study. Why specifically is it an experiment?
Because they actually have to do with the results.
You what now?
They actually had something they have to do to get the results.
Yes, we split them up, and this is called imposing a treatment. So let's get used to that vocab. Treatments. What specifically were the 2 treatments in this experiment? What are the 2 treatments that were imposed?
Split up into 2 groups.
Yes, but what did I? It's the with or without music. It's the with music or the quiet, right? So music versus quiet. And that allows me to answer a cause and effect question. Does music affect, does sound maybe affect how much you can focus and memorize? So that's why I would need to use an experiment, is to figure out that cause and effect relationship. Okay, that's it on today.